Hello everyone, in this video I show you the different types of asymptotes and how to calculate them. So what is an asymptote? An asymptote is a function that approaches another function at infinity. You can see in this picture here that the blue function approaches the red asymptote to positive and negative infinity. There are three types of asymptotes: the vertical asymptote, the horizontal asymptote, and the oblique asymptote. At first we take a look at the vertical asymptote. You can see the vertical asymptote in this picture, it's the red line here. The function is given by f of x equals to 1 divided by x minus 4 plus 2. To calculate the vertical asymptote we have to check which x values we cannot use in this function. In this function x has to be unequal to 4, because the denominator can never be 0. So the vertical asymptote is at x equals 4. Now we check the change of sign. In this picture you can see that the function goes up right to the asymptote and goes down left to the asymptote. So we have an asymptote with a change of sign here. We can calculate that by taking values right and left to the asymptote and insert them into the function. We choose the values 4.1 and 3.9 and insert them into the function. As results we get 12 and minus 8. So we can see that we have an asymptote with a change of sign. Next we have a look at the horizontal asymptote. We have the same function given by f of x equals 1 divided by x minus 4 plus 2. To get the horizontal asymptote we have to calculate the limits to positive and negative infinity. If x tends to infinity, the denominator tends to infinity and the fraction tends to 0. So the limit to positive infinity is 2. If x tends to negative infinity, the denominator tends to negative infinity and the fraction tends to 0. So the limit to negative infinity is 2. We can see that we have equal limits, so the only asymptote is at 2. We can write the asymptote as a of x equals 2. Now we take a look at the oblique asymptote. The oblique asymptote is a linear function. We have an oblique asymptote if the numerator polynomial is 1 degree greater than the denominator polynomial. To calculate the oblique asymptote we have to divide the polynomials. The result of the division is x minus 1 plus 1 divided by x plus 2. 1 is the remainder of the calculation and the denominator here is the denominator of the function. At next we calculate the limit of the remainder to infinity. If x tends to infinity, the denominator tends to infinity and the fraction tends to 0. So the oblique asymptote is a of x equals x minus 1. These were some examples of asymptotes and we are done. If you have any questions, write them into the comments.